All right, so let's build a simple circuit and talk about some basic electronics. Here is here's my favorite illustration regarding the relationship between voltage, current, and resistance. So this shows a microscopic image of like a wire with an electric current going through it and these kind of fictitious characters, where this character, the amp, is the electron going through the wire. So that represents the electric current itself, which is measured in amps. What's making the electric current flow through the wire is this voltage character pushing on the electric current to move it through the wire. But meanwhile, this character on top, the ohm, is constricting the wire and making it more difficult for the current to flow through. So with regards to electric current, the greater the voltage, the harder this push, the more amperage, the more electric current going through the wire. But the greater the resistance, the more the ohms, the bigger the ohms, the more the resistance constricts the flow of electricity through the wire, the less current is going to get through the wire. And that relationship is called Ohm's law. So here I represents current, V represents voltage, R represents the resistance, and the current is equal to the voltage divided by the resistance. So for example, if you had a 6-volt battery and you had 2 volts of resistance through the motors and the circuit, then you would get 3 amps flowing through the motor. And by the way, our motor controllers are rated for around 1 amp or just over an amp. So it's important to keep track of how much current is going to flow through in a circuit, because if too much current flows, then things could heat up or burn out, and it's something we want to be aware of. Over here is a diagram of a simple circuit with the battery, an LED, a resistor, and a switch. And the switch is just a way to break this wire or reconnect it. So when the switch is open, the electricity cannot go across the switch here and go through the wire, but when it's closed, the electricity can go through the LED, through the resistor, through the closed switch, and then back to the other side of the battery. Now, an LED is just a kind of light, but LED stands for light emitting diode, and a diode is a kind of electrical device where electricity can flow through in one direction but not the other direction, which means that it's important to plug the LED in correctly or facing the correct direction, otherwise it won't light up. And so most LEDs have one of these 2 wires is a bit shorter, and the shorter wire points towards the negative side of the battery. Also, oftentimes there'll be a little flat spot on this side of the LED that points towards the negative side of the battery. And the other thing you may notice if you look carefully is that the shape of the electrode inside the LED, on the side facing towards the negative side of the battery, or the low voltage, it looks like a little upside down L inside the LED here. And that's another way you can tell which direction to hook this up. What I want us to do next is to wire up a simple LED circuit. And we can do that just using the power off of our microbit. So on our microbit, some of these pins are kind of difficult to connect to. We're going to use a breakout board to make it easier to connect to those in a bit. We can also use alligator clips and clip on to these pins 0 through 3. And then notice over here on the sides there's a 3-volt source and a ground, which is like the negative side of a battery. And so for now we're just going to clip onto those, and we're going to wire a simple LED circuit. Okay, so here's my LED, and I can kind of see that this side, it looks like there's a little small L, upside down L there, so that's the one that points towards the negative voltage. And I have a resistor here That'll make sure that the current goes slows down enough so that it doesn't blow up the LED or make it burn out. Alright, so now I've plugged in my microbit. I can see the power lights on, which means I should have 3 volts here and ground here. And I'm just going to use my alligator clips to hold together my LED and my resistor so the electricity can go in a complete loop through this wire, through the LED, through this next wire, through the resistor, through this next wire, back to the microbit. And I'll just take a quick look again, and it looks to me like that's the side of the LED that looks sort of like an upside down L shape. And so I know to point that one at ground. And now I've done it, I've wired it up. So here the LED's lit up, and this is a simple circuit. I just have a circuit with an LED and enough resistance to not overpower it, and I'm just using the microbit as my power source. I want to show you how to hook up a simple circuit without using the alligator clips, using something called breadboard, which is a nice way to hook up simple circuits. And using a breadboard, I could just plug the LED and my resistor into what's called a solderless breadboard. So this is solderless breadboard, and I want to show you what it looks like behind. So beneath the breadboard are these little metal strips, and the metal strips have these little finger-like pieces that come up and they grab anything that sticks into these holes. And the holes are electrically connected together, going side to side and going along the sides here. So if I plug in 2 wires to the same set of holes along this edge, they're electrically connected together. And if I plug in any 2 things across here, they're electrically connected together, but not as they go from side to side. So again, take a look here. There's the little metal strips. They don't connect together from side to side, but any of the little holes on the other side of the breadboard, if I plug in there, they're electrically connected together, and all the holes along those side strips, which are called the rails, are electrically connected. This is called a breakout board, and it's extremely handy for connecting devices to the pins on our microbit, because these little edge connectors are a little bit difficult to connect to. But if I plug this into the breakout board, I can now plug pins into the same set of holes that these pins are plugged into right here. So that'll make it really easy to hook up circuits and things to our microbit. And then later we'll pull this out of the breadboard, and we'll just connect wires and plug them onto the pins that I currently have plugged into the breadboard there. So let's wire our LED circuit up to the breadboard, powered from the microbit through this breakout board, and we can see down here where the ground is and where the 3 volts is. Alright, so I'm looking carefully at the LED, and the side here on the left is the side with the electrode that looks a little bit like an upside down L. So I know I want that to go to ground, or the negative side of the battery. And on the microbit breakout board, the last 2 connectors on this side are both ground connectors. So I'm just going to plug the low side into the ground. Now electricity can flow from the microbit through this ground pin into one side of the LED, through the LED to the other side of the breadboard here. And if I want this resistor to connect to this wire, I need to plug it into any of these holes that are next to where I have that wire plugged in. So I'm just going to plug it in right there, right in one of the same holes. And now I'm going to take the other end of the resistor, and I'm going to plug it into the breadboard next to the spot on the Microbit breakout board that says 3V. And you'll have to look kind of carefully, but it's the third one down. There's a ground, and there's the 3-volt connector. And now if I plug this in to power, and I have my powered LED right here, I can see my light turn on. So now I'm powering my LED circuit built on a breadboard using the Microbit power, and I'm connecting to the breadboard with my breakout board from SparkFun. Woohoo! All right, so the next thing I wanted to show you before we really get started is how to wire up a switch. So let's hardwire a switch into this circuit on the breadboard, and that's the last passive circuit we're going to make. After that, we're going to start making the Microbit power our circuits. All right, so here I have a switch with some wires connected to either side. This is a push button switch, and when the button's pressed, it causes the switch to close, which basically means that electricity can flow through it. So to power a switch into this passive circuit, what I'm going to do is I'm going to break open the circuit. I'm going to pull out one of these wires, and now electricity cannot flow through this circuit because electricity flows from this ground pin through the LED into these pins right here that are all electrically connected, but there's no connection to the place where this resistor plugs into the breadboard and then comes back to the 3-volt power source. And what I'm going to do is I'm going to take my switch, and on these two wires, electricity can only flow through when the switch is pressed. So if the switch is pressed, it closes this inside, and electricity can flow through this wire, through the switch, out the other wire. And I am going to bridge the gap where I broke open my LED circuit with this push button switch. So again, I've plugged one of these wires into the same set of holes as where the LED's plugged in, and I've plugged in the other wire into the same set of holes as where the resistor's plugged in. And now when I push the switch, the LED turns on and off. It's very satisfying. That's low tech. We're not programming to make that happen. That's just a passive circuit with a push button switch, but still, I always find it very satisfying. I really encourage you to do this before we get started. Just wire up a simple circuit and put a switch in, and make sure that you understand how the breadboard operates, because that'll make everything that we do next even easier. So yeah, do that. So satisfying.